Hello there, children. Today we are going to work on some banking problems. Now, banking problems are the next extension that we do in 3.1. So we need to go ahead and work on all these particular problems. Alright, so the first formula we have on tap for us is this one. It is A equals P times the quantity 1 plus R over N to the NT power. Now, you've probably seen this before, but what do all these variables mean? Well, let's take a gander at them. P is your principal. It is the amount of money you deposit into the bank. So if I deposit $8,000, the principal will be $8,000. R is your interest rate. Now the interest rate, the very important side note here, the interest rate has to be a decimal. A decimal. Now, not a percentage. So, for instance, 0.25% is going to equate to 0.0025 as a decimal. Even though this has a decimal right there, it still is a percentage. So you must convert all percentages to decimals. And then you have the number of times the interest is compounded. This one's a little tricky. So you have to remember the number of times interest is compounded would be like semi-annually being 2, annually being 1, quarterly being 4, weekly being 52, monthly being 12, things of that nature. That's the number of times you compound interest. And lastly, the time. Now what you must remember about the time is in years. That's very important. So if they say 18 months, you have to remember that that would be 1.5 in T. The T would not be 18 then. Alright, so that's one formula, but we do have another one we have to deal with. Now, this next formula is pretty important because it is this. A equals P times E to the RT. E, remember, is the E that is found on your calculator. So, where does this particular thing come into play? It comes into play when we compound interest continuously. This is a special formula. I'll put a note here, special formula. It is only used when they say compounding interest continuously. So that's something you have to remember. So, every other variable holds true. What does that mean? That means your P is still your principal, R is still your interest rate as a decimal, and T is still your time in years. The only thing different is there isn't an N value because it's compounded continuously. So let's do a couple example problems here. So, John McClain decides to deposit money into a bank. He decides on depositing $4,000 into an account with 0.3% interest rate. John picks an account which compounds interest quarterly, so he will leave the money in the bank account for 6 years. What will the total amount be? Okay, so we've got a lot to take in here. So first off, we must decide which formula I'm going to use. Because it says interest compounded quarterly, which means my N value is 4 here, because quarterly is 4, because of that information, I am going to use the following formula. A equals P times 1 plus R over N to the NT power. Now I need to grab the other information from this problem. Alright, deposits $4,000 into an account. Alright, so I deposit $4,000 into an account. That means my principal, or my P value, is $4,000 because I'm depositing $4,000 into the bank. Alright, let's go through 3% annual interest. Well, and here's where you might get a little bit of trouble. 3% interest rate. That is 0.3%, but notice it has the percentage there. So I have to convert that first. Even though it has a decimal in it, it still has the percentage in it. And last bit of information for me, I have to find out 6 years. That would be T equaling 6. So now what I have done is I have filled out all the proper information needed. I put the 4,000 in for my principal. I put the interest rate as a decimal right there. I put my n value as 4 in both its proper places, and I use t. Now, what you have to remember is your calculator doesn't necessarily know what you're trying to do, meaning you might need to put this exponent in a parenthesis. If you don't, what is more than likely going to happen is to take 4,000 times all this to the 4th power and then multiply it by 6, which will get you some egregious number. As it currently stands, when you end up doing this work and you end up typing everything in, if you are very careful, which is the name of the game here, folks, being careful, because everyone likes being careful, you get A equaling $4,072.62. Dollar sign, please, because we're dealing with money. All right, let's go ahead and go on to the next problem. All right, so let's give this next one a whirl. Ilya Nikolaevich Bizgalov decides to deposit money into a bank, and this money is humongous big. He decides on depositing $4,000 into an account with a 0.1% interest rate. He later finds out the interest is compounded weekly. That's great for him. So he will leave the money in the bank for 7 years. What will his total amount be? All right, so we have to go ahead and attack this problem piece by piece by piece. So, all right, $4,000. All right, everyone's got $4,000 to spend these days, it seems like. All right, so your principal is $4,000. All right, then I look with a 0.1% interest rate. That's splendid. But remember, don't you forget to change this into a decimal. All right, and then we scroll along here, and this is what trips everyone up. Compounded weekly. Well, weekly is 52. And last but certainly not least, into a formula, I get 7 years. Now, why am I using this formula, you might ask? Other than because it looks cool, which it does. I'm using this formula because they tell me the interest is compounded something other than continuously. Anytime it's something not continuous, it brings me back to this longer formula that I've got currently in front of me. So then I go ahead and substitute and solve, or plug and chug, like a train. Plug and chug, plug and chug, plug and chug, plug and chug. Say that 10 times fast. So, choo-choo, plug and chug. Or substitute and solve if you want to get all fancy and not have Mr. Kelly come over and yell at you at some point. Which, nobody likes that. All right. And so then we go ahead and fill it out. Now, what you end up getting here is A equals, don't forget your dollar sign. All right, you get 4,028.097. So if you round it to 0.10, perfectly fine, since it would be 0.097. Now, why am I rounding it to 2 decimal places? Because it's money, folks, and, well, we don't round to odd numbers like 3 decimal places with money. All right, Sean Lee decides to deposit money in a bank. He decides on depositing $8,000. Look at him, big spender, big NFL middle linebacker, although he's a terrible ladder golf player. Into an account with 0.25% interest rate. He later finds out the interest is compounded continuously, so he will leave his money in the bank for 5 years. What will the total amount be? All right, and folks, we have this, compounded continuously. First time we've seen that, and that, my friends, denotes this formula. Anytime you see compounded continuously, this formula is going to show up. So, it's the PERT formula. Why? Because continuously means n goes to infinity. Now, we can go ahead and go do that proof if you'd like, but trust me, the limit definition for E is found in our regular formula. More to come from that later. Let me just go ahead and convert all these numbers here that I need. All right, Sean, let's take your $8,000. That's a principal. Now, again, I am able to do this because I am of the ability of having different colors. If you don't, just remember to write down your pertinent information. That way, if you ever make a mistake or an egregious error, you can go back and check to make sure you put the right values in the right spots. That's super important. So now, when I go ahead and fill this information out, I go ahead and go A equals 8,000. E, which is a small e, or e to the x in your calculator, 0.0025 times 5. All right, and then we go ahead and plug and chug that information. When you finish this up, A equals, don't forget the dollar signs, 8,100.627 or 0.63 because we round up. And there we go. Okay, now, these aren't overly terrible. Given information over here, we plug and chug, substitute and solve for A. Where we're going to get later in the chapter is we'll be given A and some other of these particular values, but we'll be missing one of them, and we'll have to go solve that. But we won't run into that until section 3.4. You are now ready to tackle your homework assignment. Oh, happy days are here again.